Okay, so anyone who was knocking around back in the 80s knows that mainly software came on cassettes. It was the cheapest way to get software. It was also the slowest way for software to load. Also, it was available on diskette. And this was faster, but it was more expensive. A third way that software was available was on these little ROM chips that were usually found in cartridges for many, many systems like the Commodore 64 or the Atari 2600, for example. But for the Amstrad computer, you could also buy ROM chips like this, pre-programmed. Generally, you weren't talking about game software. You would have been talking about utilities and productivity software like word processors and that kind of thing. Now, very much like a disk needs a disk drive to be used, or a tape needs a cassette drive to be used, a ROM chip needed what was called a ROM board to be used. And a ROM board resembles this. This ROM board was featured as a DIY project in the December 1988 issue of Amstrad Computer User. Phil Craven designed it, and he published the article, a little 3-page article, well laid out and well explained, and put together in a way that was easy to read and pretty much put together by anyone. It consists of a couple of resistors, a couple of capacitors, 3 logic chips, a diode, and a connector. That's pretty much all that's to it. The problem comes when we realize that there's 250 solder joints or more at the back, and many of them are very, very close together. They're about 2.5 millimeters apart. And seeing as we can't have any shorts or any of that kind of thing, it can pose a problem. Now, the way a board like this works is that back in the day you would have bought these ROM chips pre-programmed with, for example, a word processor on it, and it would plug into the board, and then the board would plug into your computer, and you would be able to launch your processor, your word processor, anytime you wish just by issuing a command. All the memory in the computer, if it was a 6128, all the 128K was available to you for writing your letter or whatever, as the information on this ROM could be accessed directly by the Amstrad, so it didn't have to load it into its own memory. And the other advantage, of course, was it loaded instantaneously. You would still have to save your work out to a cassette or a disc, but the actual program itself was available to you. There were many, many different products available on ROM chip, and they could be used in this manner. But the beauty of this today is that an awful lot of games and utilities and all that kind of thing that were never on ROM chip before have been converted over and put on ROM chips. So nowadays, seeing as this technology is after getting kind of cheap, we can program ROM chips ourselves with Amstrad ROMs, and we can use a board like this to launch pretty much anything we want. So this is, yeah, it's a nice little project that I threw together. So what we'll do is I'm going to take off the protective cover I put on the back of the board, and I'll show you pretty much the way it's wired. And while I'm doing that, I'll make the most of it to stick in this little button. And I read also on the Amstrad CPC wiki that a little reset switch can be installed using the expansion port. So I said what I do is, as I had this plugging in anyway, I would add this little button onto it and show you how I do it, so that we can press it at any time to reset the Amstrad without having to power it off and power it back on if ever we have a problem, or if we just want to quickly power down and power back on. So I'll take this cover off and show you what's on the inside. Now, here we go. This is the rat's nest of words that we have going on the inside here. Basically what's happening is we've got address lines and data lines running from the edge connector on the CPC, and different address lines and whatnot are coming from here, and they're going up to the ROM chips. So like address line 10 would correspond to address line 10 on the ROM chips, and it's daisy chained right across to address line 10 on each and every ROM chip. So yeah, that's the way it's put together. You can see that it's a kind of complex thing, and it's kind of a mess of wires as well. Now, what I will say is there are 0.1 microfarad capacitors required for each of these chips. So they should be going from the 5 volt point here down to the ground point. But I didn't put them in. I said I'd wire up everything else and I'd put them in afterwards. Now I was wrong in saying that, because in order to put them in, I'd end up making all kinds of shorts and all that kind of thing, because everything is so damn close together. So I actually omitted them. In the end, I said no, what I'd do was I wouldn't bother, and if they were really needed, I'd solder them onto the ROM chips themselves. But it seems to work away fine without it. I did, however, put on the main smoothing capacitor, but I didn't put it on the board because where it was located, it prevented it from getting plugged in. So what I did was I just left it kind of hanging loosely, and I put a bit of shrink wrap around it so it wouldn't cause any shorts. And it's sandwiched in there nice and tight between the back and board, so it's not going to go anywhere. It's in a good place there, if you like. And no, that's it. That works away pretty much the way it should, and it is it's solid and it works well. It hasn't given me any hassle so far anyway. But that's the back of the board. Now, so my soldering iron is warmed up and we should be ready to go. So what I want to do is, I have it open, is I want to put this little button, this little switch button, I want to install it somewhere here on the board, just in here beside this logic chip, and that way when it's plugged in I can easily reset the system if I need to. So I'd say I will just probably put it in somewhere there. I'm hoping that none of the wires on the back now are going to prevent me from soldering it in place. And put a little drop of solder on my iron. I'm going to ease these up out of the way. I'll just touch the solder to the pin. Okay, so we're after applying our little bits of solder there. What we want is, I'm going to use black here. I've got this wire wrap wire, is what I used to actually make the whole board. It works well in that it's very easy to strip. You can strip it with your fingernails, like this. And also you can strip it in the middle without actually having to cut it. You can strip it with your fingernails, which is how I joined all these together. It works great. It's the old wire wrap wire. Now, so what I'm going to do is, I'm going to join this pin here to ground. A bit of solder here on this. See if we can get it to stick to the wire a bit. And we will put just here a little solder, that in there good and tight. There we go. So that's soldered good up. Now, so what I want to do is to bring that on here nice and gently and give it plenty of slack, and we'll bring it just down to the ground point here, so that everything is going to ground on that. And the idea behind this switch is that when pin 40, which is right here, is shorted to ground, it will reset the Amstrad and reset it in the proper way, because pin 40 is what's called bus reset. There's also a switch that's called reset. It's pin 41. But pin 41 resets the system, but it apparently doesn't reset the PIO, and that results in a reset, sure, but it apparently isn't reset the way it should be reset. Now, I'm only telling you what I read. What that means exactly is a little beyond me, because I didn't study into it too much further. But yeah, that's apparently the correct way to reset it, is to go to pin 40 and perform a bus reset. So I will use here's a little bit of purple wire for our reset line to go to the bus reset on pin 40. So I'm going to join it to the other side of the button here. So we do pretty much exactly the same thing, and we bring it down to pin 40. And I'll show you the way that those pins have been. Actually, the way these pins are numbered, they're numbered from pin 1 to pin 50. So this here is pin 1, and this down here is pin 2, and pin 3, and pin 4. So what you have, in fact, is you have all of the odd pins going across the top. You have 1, 3, 5, 7, and all the even pins going across the bottom, which is 2, 4, 6, 8. And so it's going from pin 1 up to 25, and then from pin 2 up to pin 50 at the end here. So we can count exactly what pin we want to go to. So I believe that this here is pin 40. So we go like that. There would be 50, 48, 46, 44, 42, and pin 40 is right there. So that's where we want it to go to. Now, there we go. Because pin 40, I want to go to pin 40 and only to pin 40. I don't want to be shorting pins that shouldn't be shorted. So we will bring it to pin 40, and then we will check once we have it soldered that we haven't made any shorts anywhere across the board. Yeah, so that goes there. There's your pin 40. A little bit of solder to the pin. There we go. I want to make sure that this isn't making contact anywhere it shouldn't, so it seems to be fine. It's not making contact on any of the other pins. It's beeping off itself, of course. And this guy is going to Earth, so he's beeping on Earth, and that's all he would beep on Earth here as well. Yeah. And this one here, like I say, shouldn't be beeping on anything else. Good. It's beeping on itself. I will put this board back together, put a little cover on it, and we'll go have a look and see how it works. Now, so it's all back together, it's all back protected again, and hopefully I haven't introduced any shorts to it or anything, and hopefully it'll work away. And now with its new little reset switch, so there we go. We'll plug it into our Amstrad and go over there and we'll take a look-see. Now, here's my ROM board, Amstrad. This guy here will plug in to the expansion port on the back. There we go, nice and plugged in. We flip her on, and there we go. We've got a screen up on it, and I'll show a few close-ups there, but it says Toolkit 1985 by Bebugsoft, Parados version 1.1, copyright 97 by Quantum Solutions, Multimark version 1.1, ROM enabled, use So what I've got here is it's after listing the contents more or less, or the titles of the contents of 3 of the ROM chips. And the 4th ROM chip, I put Arkanoid on it, just to show now the game running on it. But what's very useful to have is this toolkit suite of tools, because what that does, it contains a number of tools for ROMs as well, in fact. So if I issue the command ROM, it'll give me a list of all the ROMs available on the ROM board, well, and in the computer too, because we're going from ROM 0 to ROM 8 is what's displayed here. So what we have is ROM 0 is basic. That's the basic ROM that's in every CPC there is, be it 464, 6128, or any of them. It's the locomotive basic programming language, and that's on the inside. It's in position ROM 0. Then I have ROM 1 is empty, you see, so it says here 8K, but it's empty. ROM 2 it sees as Arkanoid, that's this ROM here, so I have Arkanoid programmed on that. ROM 3, which is here, it sees as initialized ROM. Now, initialize ROM is, I'm not actually sure what I have on it. It must be Multimark version 1.1. That's seen as initialized ROM in here. ROM 4, which is this one here, has PDOS on it. PDOS is Parados. That's the disk operating system for the CPC, which will let you use up to 720 kilobyte disks. So if you were using a 3.5-inch disk drive instead of 3-inch disk drive, you'd be able to use Parados in order to access the full capacity on that disk and all that kind of thing. Now, I'm not sure if it can be used this way just off a ROM board, or if the actual physical CPM DOS type thing that's in the CPC would have to be removed, because well, I'll get into that in a minute. But in ROM 5, which is 1, 2, 3, 4, 5 here, I have the toolkit. The toolkit is actually contains this program that I'm running here, the ROM program, which will let us interrogate what ROMs are here on this. So that's the toolkit one. That's in ROM 5. ROM 6 is empty. Now we come to ROM 7, which is on the inside of this system. Now, ROM 7 is available in a 6128 because a 6128 has a disk drive in it, so it needs a DOS, a disk operating system. And DOS for the 6128 is contained in ROM location 7 on the inside of the Amstrad. Now, like I was saying, if you're using Parados, it may be necessary to remove ROM 7 physically from the inside and replace it with the Parados ROM. I'm not sure the ins and outs of it, because I haven't delved too deeply into that. But I've read that in some cases it's possible to use it on a ROM board, and in some cases you need to completely remove it or to have some kind of ROM switch set up on the inside of the CPC in order to use it. So, to be honest, I don't know enough about it to say exactly, but these are the ROMs anyway that I have available. Now, you saw here that I needed to run the ROM command in order to see this lot. So for Parados, for example, I don't know what commands to run. I could try Parados. That doesn't do anything. I could try DOS. DOS. That doesn't do anything. I could try PDOS because that's what it's called. So, but PDOS doesn't do anything. So without the manual, I don't know what commands to type. But again, thanks to this little toolkit guide that I have installed here in ROM location 5 that we just ran the little ROM command from, if I run tools, which is its full menu of what it has available, you see this is the screen we get. And we've got all kinds of commands in here that we can use with disks and all that kind of thing to edit and copy disks. But there is also, well, there's actually what's quite useful is the format command for disks as well. But here in this, we have the ROM command. Now it's a little bit more beefy than what we just ran there by typing ROM. Because here what it'll do is it'll ask us what ROM number do we want to look at. So Parados, as I recall, is in ROM location 4, I think. So we have selected the option ROM, and we want to know about ROM location 4. We want to know about Parados. So it's telling us that in ROM location 4 there's PDOS, and it's a 16 kilobyte ROM chip. But these here are all the commands that it has. So we have CPM, disk in, tape, tape out, B, user, ERA, render, drive, A, tape in, disk out, disk. So most of these are commands that are actually available with the Amstrad DOS anyway. They're shared commands. But here, for example, we have drive. So if we try drive, we'll see it loads up the Parados menu, where we can put in a disk, for example. I'll stick in this disk here, and we can log the disk to see what's on it. Log drive A. It accesses the disk and it gives us a list of the contents of the disk, and we can copy these contents to another disk. We can manipulate them in different ways by changing the attributes, by moving them around, by renaming them. There's all kinds of stuff we can do in there. But it's kind of a way that we can change things around on disk without needing extra programs and all the rest. Then if we want to escape out of that, Control Shift and escape, and it reboots our Amstrad. Of course, we've also put in our little reset key, and we'll see if that works or not. Little reset button we put on the board. We'll see if that works in a couple of minutes. So like I say, we're after looking at Toolkit, we're after looking a bit at Parados. Multimark is a program that's actually quite useful as well. It can be used to format disks, and it can also be used to check disks. So it'll check a disk and see if it has bad sectors or anything. But the lovely thing about it is what it'll do as well is any of those bad sectors, it will mark them, and it will render them unusable by filling them with data. So you end up with the usable space on a disk that's good and useful available to you, and all the bad space is put in a file called error. So a bad disk is made good, more or less. Anything you save onto it, you can be sure it's been saved onto a good location of the disk, and it's not going to end up corrupt or anything like that. So in order to run that, it actually tells you what to do. It says to use the little command key guy here and to press to type in and that will give us our multi-mark menu. So for example, if I want to test this disk, and there are actually errors on this disk, I would insert the disk like this. I want to use drive A, and I would just press V for verify. That's how it works. F is for format, M is for mirror. To mirror a disk is pretty much copy disk to disk. S is for setup, which isn't very useful to us when we're using ROMs, because to change the configuration file, it can't be written back to ROM. ROM is read-only memory. We can't actually write to it. Restore is we can restore a catalog to a disk. Quit is obviously to quit. Dir is to list the directory structure of the disk. But we will verify this disk and see what the story is. So it asks us, should it print out a report? We don't have a printer connected or anything, no, so don't print out a report. So it checks the disk, it reads the disk catalog, and it'll start trying to read the disk. But it's having trouble with that little disk straight away, because that disk is in bad shape. So it's not managing to read the disk. I bought a lot of 8 disks quite cheaply, and 2 of them were pretty much unusable. So it's going to verify the tracks. It'll pretty much find they're all bad, is what's going to happen here. So it's saying sector 1 is corrupted. You say, okay, that's fine. On to 2, it'll find all the sectors on this disk are corrupted because the disk is bad. But no, that's pretty much what it does. And by the time it's finished, it'll write a little file that'll use up all the bad sectors and leave the good available space remaining available to the user. So that's pretty much that program and what it does. I'm going to quit out of it. Of course, it's not going to let me quit now. So we will try here. We will use our reset button. See, does it work? There we go. We're reset. We're back out. So we'll see that our disk is still working. That we didn't do any harm to that. There we go. So we've got our disk drive is still working, everything's still working away fine. So finally what I'll do is I'll show you Arkanoid, and to run Arkanoid, again, if we didn't know how to run it and we had the toolkit installed on one of the ROMs, you would type tools. Well, actually what you do in the very beginning is you would do as we did before, and we will type ROM. And it tells us that Arkanoid is in ROM slot 2. So then next thing we do is we type tools like that. We go to R to interrogate our ROM, and we know that it's in slot 2. So it tells us we have Arkanoid, and the command to run it is Arkanoid. So in order to run it, we can reset our system, and we go ARKANOID, and there we go. We have Arkanoid running. So 1-player game. Yeah, so there you go. That's pretty much how the ROM board works. If you have a ROM programmer and a chip eraser, you can erase you can blank out your ROM chips. You can program them up with. I'll put a link in the description to where you can find whatever ROMs, utilities, games, all that kind of thing that can be used. And it's like I say, it's a fun little project. All in all, it took me maybe about 8 hours to build it. Does it really have any utility today? Maybe not so much, but it's a fun thing to have. It's a nice little thing to go back and look at. I mean, these, when they were available back in the 80s and all the rest, they were quite expensive. They were over £50 sterling, and it's interesting that this particular ROM board at the time was under £10 sterling to build. And it's buildable, but like I say, it takes there's about 8 hours of work in building it, just all the wires and all the wiring system that's in it. It's but like I say, it's a nice little project. Listen, I hope you enjoyed the video. I hope it was informative for you. All the links and all the rest are in the description to everything, the plans for it, absolutely everything. I've put in the description below. And if you like the video, give us an old thumbs up, think of subscribing. Leave a comment down below if you have any questions, or if there's anything you'd like to add, or if you used any of these boards, or if there's any ROMs you've used that you found to be useful or good. And we'll see you in the next video. Thanks very much for watching.